Hello and happy birthday. First thing we're going to do is take a look at dot product of 3D vectors. You've got two vectors here, U with the components A1, B1, C1, V, A2, B2, C2. The dot product for 3D vectors is the same really as the dot product for 2D vectors. You match up the horizontal, the vertical, and now our new three-dimensional coordinate here, and multiply them by each other. Your end result is going to equal a scalar. It will be one number. It will not be a vector. It has no direction. That's it. I don't want to spend a whole lot of time on that because it's pretty simple there. Let's move on to the real meat and potatoes of this particular thing. Oh, well, you know what? Let's do a quick dot product just for the heck of it. Okay, so again, I pair these guys up, so I'd get 1 times 3 plus -2 times 2 plus 5 times 0. 3 minus 4 plus 0 equals -1. So U dot V is equal to -1. That's it. Pretty simple. Dot product of three-dimensional vectors. Let's look at direction angles. And this is similar to what we've already done. So far, we've looked at the angle of a vector from the positive x-axis, and we've called that alpha. That's really been the main thing that we've done so far. We're going to build a little bit on that now. What we will do is we will look at three directions that the vector is going in. Here is our original alpha down here. Actually, let me use the highlighter. There we go. Yeah, down here. This is our original alpha that we have seen before. Now we're adding to it the angle from the positive y-axis. That's right here with beta. And that character right there that's pointing to is beta. And then the last one that we've got is the angle from the positive z-axis, and that is gamma. That's this guy right here. I would strongly recommend getting this down into your notes pretty much exactly as it is here, because this will help you visualize what we are working with. To find these, it's actually pretty simple. So if I have a vector AI plus bj plus ck, the cosine of all of these is just going to be related to that particular component of the vector divided by the magnitude. That's it. So if I want to find the angle from the positive x-axis, a is my horizontal, and a over the magnitude of v, that's the cosine of alpha. And then once we've got the cosine, then we can find the inverse cosine. It's really cake. So again, this should be something that's almost identical in your notes. Let's go ahead and start applying it. So I need to find alpha, beta, and gamma for this vector, v. First thing I need to do is what? I need that magnitude. So that's going to be the square root of 3 squared plus 0 squared plus -4 squared, which gives me the square root of 9 plus 0 plus 16 equals the square root of 25, which is just 5. Nice number. Now, I want to find the cosine of alpha. Cosine of alpha is equal to a over the magnitude of v. Substitute a is 3. 3 over magnitude of V is 5. 3 over 5. Therefore, alpha is going to be the inverse cosine of 3 over 5, which gives us rounded to the nearest hundredth, or actually let's go to the nearest degree, 53 degrees. Not bad. Cosine of beta is equal to b over the magnitude of v. B, right there, there's 0. This one's going to be pretty simple. Beta is equal to the inverse cosine of 0 over 5, which is still just 0. And that one should look fairly familiar. That's 90 degrees. Lastly, cosine of gamma is going to equal, I apologize for the bad gamma. It's not my best penmanship. Go back, grab C, that's -4. -4 over 5. So gamma would equal the inverse cosine of -4 over 5, which equals about 143 degrees. So there we've got it. We've got alpha being 53 degrees, beta 90 degrees, and gamma being 143 degrees. That's it. Why don't you practice on one? So find alpha, beta, and gamma for W, when W is, let's say that is 7i plus 2j minus 3k. Do that for practice, bring in any questions that you've got, and have a most excellent day.